Welcome to EcoFun. Today we'll have a look at the first physical water quality parameter, which is the solids. So, how many solids are there as per the size of the particle? There are mainly three types of solids as per the size. First one is the suspended solids, which are of size greater than 1 micrometer, and colloidal particles, which are of size between 10 power minus 3 micrometers and 1 micrometers, and dissolved particles, which are of 10 power minus 3 micrometers and less. So the size of the particles that is been defined here will play an important role in choosing what type and size of filter to use to filter these particles out. So you can see here on the right side of picture there is a filter known as Wattman filter, and this Wattman filter is used to filter out the suspended or colloidal or dissolved solids, and the size or the pore size of the filter plays an important role in filtering out the solids type. Suppose if we choose a pore size 1.25 micrometers, it ensures that particles greater than 1.25 micrometers will present on the top of filter layer, and remaining less than 1.25 micrometers will pass through the filter. So these particles can also be classified as per the filtration also. So as per the filtration, the colloidal and dissolved solids are together considered as the filterable particles, and the suspended solids are considered as non-filterable particles. In reality, what happens is that these colloidal particles or dissolved solids, they get trapped inside the suspended solids. Suppose if you consider a suspended solid like this, in this suspended solid there may be some colloidal or dissolved solids trapped in the inside this suspended solid, and the particle on this whole level is considered as the suspended solid, but it is a mixture of suspended and colloidal and dissolved solid. So the reality will be like this, but the good news is that their fraction would be very negligible. The majority of the particles that's been retained above the filter or on the filter are most of them come under the suspended solids. So we use the term suspended solids equivalent to non-filterable, and the dissolved and colloidal solids are together called as the filterable particles. So if we consider the examples of each of these solids that we discussed earlier, the clay, silt, and organic debris are considered as the suspended solids, whereas the colloidal solids are starch and gelatin, and dissolved solids come under the glucose, salt, etc. So, what's the difference between the colloidal solids and the dissolved solids apart from their size classification? So, sometimes these colloidal solids, they mimic the behavior of the dissolved solids such as glucose. If you mix a glucose in the water and if you mix starch in the water and boil it, they may look the same, but in reality they are different. These colloidal solids sometimes have the property to mimic the dissolved solids. You can see here the picture which is present on the left side is glucose, and the picture which is present on the right side is starch. But basis on the perception, you can get easily deceived because they look the same. But in reality, this is a colloidal solution. This is a colloidal solution, and this is a dissolved solution. So, another thing that we have to remember in case of dissolved solids is that the solids which are surrounded by water molecules at molecular level is termed as a dissolved solid. Suppose if you consider a glucose molecule, at this molecular level it is surrounded by water molecules. And if you consider salt also, suppose it splits into sodium and chloride, but at ion or the molecular level, it is surrounded by water molecules. So these together are called as the dissolved solids. But the starch or the gelatin, though they may look like the dissolved solids, they are technically suspended. Okay, so we'll meet in next lecture. Please subscribe to my channel and like my video. Thank you.